So along with continuous, we can talk about a function being left continuous or right continuous. Continuous. So even if a function isn't necessarily continuous, it might be left continuous or it might be right continuous. So the definitions here, a function is left continuous if the limit as x approaches your number c from the left of f of x is f of c. So this time we're not saying that the limit had to be f of c, we're saying that the limit just from the left had to be f of c. We also have that a function is right continuous if the limit as x approaches c from the right of f of x is f of c. So we're not saying that the entire limit had to be f of c, we're saying that just the limit from the right had to be f of c. So let's do two different examples here. First example, let's let f of x be x for x less than or equal to 1, 5 for x greater than 1. And I want to know, is this continuous at x equal 1? Well, first let's draw a picture. I think that might be helpful. So I'm going to draw a picture here. This says that it's equal to the function x, which is just a line going through the origin, for x less than or equal to 1. So let's see, there's x equal 1, here's 1 here, and there's the line y equals x. Now what is the function y equals 5? That's just a horizontal line. So there's that part. Now it's definitely not continuous at x equals 1. You can see there's a jump discontinuity here, but is it left continuous or right continuous? Well, let's see. I'm going to ask myself, what is f of 1? So come up here to your function, plug in 1. It says plug it into the first piece, so it's 1. Okay, what's the limit as x approaches 1 from the right? We'll start with that. As I approach x from the right, my function values are 5, so it's not right continuous. Because the function, the limit from the right is not equal to my function value. Now let's look at it from the left. As I approach 1 from the left, what's happening to my y values? They're going to 1, which is equal to f of 1. So we say this is left continuous. It's not continuous because these two values were different. Go back to your definition of being continuous. But it is left continuous because the limit from the left was equal to my function value. Let's try another one. This time let's let f of x be x minus 1 for x less than 0 and x for x greater than or equal to 0. So let's graph this. This says that I should graph the line x minus 1 for x less than or equal to 0. So the graph x minus 1 is a line with a y-intercept of negative 1. So it looks like that. And I don't want to include the point at 0. And then I want to travel along the line y equals x for x greater than or equal to 0. Okay, so there's my function. We want to know, is this left or right continuous? So let's first, at 0. So is this left or right continuous at x equals 0? So you can see that, okay? So first let's start with, what is f of 0? Well, if I go up here, f of 0 says to plug it into the second piece, so 0. Now, let's look at the limit as x approaches 0 from the left. As I approach 0 from the left, what's happening to my y values? You can see they're going to negative 1. That's not equal to f of 0, so it's not left continuous. And we said f of 0 was 0. And now the limit as x approaches 0 from the right. Let's see, as I approach 0 from the right, you can see my y values are going to 0, so I get 0. And that is equal to f of 0. So f of x is right continuous at x equals 0, because the right-handed limit was equal to my function value. So I found my function value and saw which side of the limit was equal to it. That tells me that it's right continuous. So left continuous and right continuous are two different ideas. It just talks about, is on the left am I continuous, or am I continuous on the right? So a function could be both. In that case it is just continuous, or it could be one or the other.